And they
Humans are animals!
I understand that, but they know what I'm talking about. Other than a human, what would you be?
See,
A sea louse.
the question you ask
A sea
should
louse.
ask, it should be the question that you intend to ask.
Exactly.
You're a sea louse.
I knew that I should have said except a human. You can't choose a human or something like that. But I was like, what are the chances that they're gonna
Well,
go?
no, maybe not.
Okay, just
Is
know.
God an animal?
What's
No, God is an inanimate being, probably an eldritch being, who
I
is
don't think that.
quasi-dimensional and
Eldritch?
probably
Is this
doesn't exist.
Cthulhu mythology?
Yes,
And just know
and
that
probably
there's
doesn't exist either.
always a right answer.
Alright, we should do an awkward transition into physics. And this is the awkward transition.
Well, nothing better than God to start science.
Any questions related to physics?
What's G2 Kombuka?
Shut up.
You haven't looked it up yet?
I tried. I found a person. I didn't figure out what you meant.
Oh, just so you guys know, we're gonna have
If I remember near the end, I'll play a little video which will explain. Alright, so one last topic is rotational motion before we get into the harmonic motion. Harmonic drawing. Oh, brass. Like that. No, we'll make this one more.
How thick is the rod? Does that matter?
Sorry, what'd you say?
How thick is the rod? Does it matter?
How, no, that's why I put thin down to just indicate. we
I
don't
thought
care
that's
about
a
it.
twin.
Oh, no, that. Alright. If we wanted to get really picky about it, then yes, the thickness does matter. However, the typical, at this level, offset is just, it's called a thin rod, in which case any thickness to it is gonna add such a small amount to anything we need, we'll ignore it. So the question is, I need to get one other piece of information. Let's see, what number have I not used yet? Let's go with,
0.2.
I'm using a 2 though, so let's go with 0.6 meters per second. And the question is, so this is a piece of putty. Putty will stick to rod. What is the final angular speed? Omega initial is equal to 0 radians per second. Oh, it's on.
So it starts at rest.
Yeah. Overhead view, it's a frictionless table, so I'm not worried about that part. All right, go.
Alright, go.
Is this a test?
All right, so what's the word for when the putty hits the stick?
Collision.
Yes, and when there's a collision, what is the main concern? Or the main physics principle involved?
How much kinetic energy is,
Conservation.
How much colic energy?
Conservation. How much energy is conserved?
I say how,
Oh,
it's how much kinetic energy is lost.
That is not the question.
What?
What is the final velocity?
Yeah, no, the primary physics concern, I thought you had said it, Ava, and then apparently I misheard.
Conservation of momentum?
That's the one.
She said that, she said that originally,
Yeah, but there were people talking over it, so I wasn't 100% sure. So it is a conservation of momentum problem. And pro tip, if you have a quiz on the momentum chapter, then probably momentum is involved in the problems. So we do have a conservation of momentum here, except for the fact that, yeah, I can figure out what my momentum is beforehand, but afterwards, this thing is rotating. So the primary, it's not just conservation of momentum, but we do have to worry about conservation of angular momentum. So we just have to figure out what is the angular momentum beforehand and the angular momentum afterwards. We could find linear momentum beforehand, but linear momentum afterwards becomes a little bit tricky because it's going to be rotating. And also typically, another pro tip, if the putty is involved, most likely it's going to stick. And yes, I know, silly putty will stick sometimes and bounce sometimes, depending upon how you mess with it. All right, so angular momentum. What is the formula for angular momentum?
Well, it is.
Alpha equals I omega squared? Wait, what?
No, that's not correct.
That's very wrong.
Yes.
It's actually inertia times omega.
All right, we recall
That's angular acceleration.
regular momentum, P equals mv. Angular momentum, L equals I omega.
Yes. Inertia.
As with regular momentum or linear momentum, we find the total momentum beforehand by looking at the angular momentums of each object and then adding them. So I need to figure out what is the moment of inertia of the ball that's traveling in a straight line.
Angular momentum?
Yes, what is the angular momentum of that 1.5 kilogram ball?
I'm not sure about angular, but it's just 1.5 times 0.6.
That would be the linear, correct?
Okay, so is that a solid sphere?
Yes.
So it'd be 2/5 mass radius squared. How am I supposed to know what the radius is?
I didn't give it to you. So how do you deal with that? If I didn't give you the radius. Or I could give you the radius, we could add another dimension to the problem.
Wait, is there a way to find the I without the radius? I'd rather you teach me how to do that than just give me another variable.
So the question is the size of this ball significant or not? How does it compare to the other sizes here? If I didn't give it to you, either I made a mistake or I'm trying to indicate that it's insignificant. There should have been some wording in here, like it's a point mass or something like that. If I say point mass, that means that we don't worry about the dimension. Indeed, the moment of inertia of a solid ball rotating about its central axis would be 2/5 mr squared. But is it going to rotate about its central axis?
Oh. The putty?
The putty.
Wow.
All right, while they're discussing it, let me look over on this side.
Honestly, I was just thinking, not like.
Where's the axis of, if you're doing angular stuff, you have to have some axis of rotation. Where is the axis of rotation?
At the
Center
little dot on the rod?
Yeah, right there. There's the axis of rotation. And again, I should have stated that, but I was hoping that you sort of saw it, at least one of you did.
That's the axis of rotation of the putty?
Yeah, that's
Of the
Sorry.
rod.
Yes,
of the putty.
No, see, like, that's what's confusing. Oh,
But isn't it only of the putty when the putty is on the rod? Not whenever it's approaching the rod?
Can't the axis of rotation be anywhere though?
It can.
except it's, because it's, yes, it could be, but because does have a natural axis, it's gonna pivot about that point.
So then
It
if
is
it can
much
be
simpler
anywhere
to
and
pick
apply
up.
to everything, if it can be anywhere and apply to everything, then it makes sense that the putty would have an axis of rotation there, right?
If it could, but if you pick someplace other than this axis of rotation here, so let's say we picked a point there to be the axis of rotation.
Yes.
Before the collision, it's gonna be as easy or as hard as figuring it out what it is if that were the axis. But if this is rotating this way,
Yeah.
and that's your axis of rotation,
Yeah.
that becomes incredibly difficult,
Yes.
because not everything is moving the same speed, same angular speed about that point. So that becomes an incredibly tricky math problem.
Okay.
Because this is a natural axis of rotation of this thing that's swinging, everything that will be traveling at the same angular speed after the collision. And if that's what it is, the axis of rotation after the collision, it really needs to be that before the collision. Because that would be, if I chose this before and this after, I'm changing my reference. It's like saying, well, I hat's positive this way, okay, now we're gonna make I hat positive that way, and before you'd actually finish the problem. Let's make that I hat.
Okay.
So we pick a natural axis
Of rotation.
because it basically
Makes things
is
easy.
so much simpler than the calculus mess we have to get into.
And there's only one axis of rotation in these types of problems usually.
Yeah.
So then it makes sense why it applies to the ball. Or putty.
Just the last thing, I heard the ooze.
So if there's typically only one axis of rotation in the problem, then and there are two objects that it's applying to, then it makes sense why one of the objects, even though it's not touching it yet, is important to that because there's only one, and both of them have to have angular speed. Well, velocity.
Yep. I'll buy it.
Yeah.
All right, did the ooze come with a conclusion, or?
Yeah.
I'm proud of myself. I did that.
That's good.
I got some.
All right. The axis of rotation is not where the ball is. It is not rotating about its center of mass. Therefore, how do we find the moment of inertia?
Can you say what you said?
I think now the radius would be the distance from the ball to the axis of rotation.
Okay. And are we still plugging into 2/5 mr squared?
Yeah.
Yeah. Oh, dang it. Okay, inertia, guys, what's inertia again?
The typicality.
No,
That
what's
thing.
the resistance of it? No, I mean like.
The
what's
tendency
linear-
for a thing in motion to stay in motion, or a thing that doesn't want to be in motion, aka isn't.
Oh, it's
just
mass.
it- Oh my gosh.
What's the linear? I was asking what the linear part of it was. It's your mass. So, Dr. Fox, can you just give me like a hint? Don't tell me what the answer is, just give me a hint.
All right, I'll sort of repeat that. The axis of rotation, we know the formula for the axis, for the moment of inertia of a solid sphere when it's rotating about its central axis,
Right.
2/5 mr squared.
Right.
But we have moved the axis to a different place.
Okay.
Okay, so
So how do you find the moment of inertia when the axis has moved?
How do
do you find the moment of inertia when the axis has a
For visual. Instead of the axis of rotation being about this axis right here, the axis of rotation is about this right here.
Right.
Yes.
So
What's
is
the
it a
relationship?
hollow?
What?
Is it a hollow sphere?
No, what's the relationship between this axis and this axis?
They're equal.
They're connected.
Equal how and connected how?
I'm
The
guessing.
angle between the 2 points.
But
The
how-
angle between.
Between the two
Expand on that,
points.
Abby?
Because if you have the one at the top and the one at the bottom, it creates a horizontal line, and then there's already a vertical line going this way, the angle is right there.
Oh.
But like,
Oh,
what am I getting?
that-
Yeah.
Thought you were going a different direction.
Okay,
So
so you were somewhere.
so
Angle
matters, angle matters, so, what?
Can you repeat the question?
The angular displacement, maybe instead of 2/5 with the angle.
Now, have a little bit of consideration for, I'm not a great drawer, so just go with what you think I intend to draw here.
I know,
No, that's not usually gonna work out for me.
that's a road. Sorry, no, continue, I apologize. I thought we were like, supposed to charades. Yeah.
All right, what is this thing up here with the?
A line.
Thank you for the pedantics representation of the line. All right, I got another one down here.
Yes.
What can you tell me about those two lines?
Parallel.
Ah, so if I have an axis here and an axis here, what can you tell me about the axes?
They're
Parallel.
Ah, parallel axes. Where have we seen that before?
The parallel axis theory!
Yes.
Oh my gosh!
There are other ways of getting to the same place, but this is one way.
That was gonna be the right.
So the moment of inertia of the ball, this is initially, is going to be the moment of inertia of the ball about its center of mass plus mh squared.
Isn't it putty?
Yeah, it's a ball.
It's a ball of putty.
Okay.
Now, this would be 2/5 mr squared plus h. What we really care about, this ball could have come from who knows how far away. What we really care about is just before impact. In other words, the shift of it. Let's see if we can get a stunning visual effect. When the ball is here, how much did the axis shift?
Is that a straight line?
It's supposed to be.
Oh, okay, then it's,
1.3 meters.
Yes,
yeah. I thought it was that.
because the distance from here to here would be 2 meters minus 0.7, so it shifts 1.3 meters. So this is going to be the mass times 1.3 meters squared.
But Dr. Fox, you don't have to do this, I just want you to know, you put 0.03, not 0.3, I just want you to know.
Oh, thank you. That was the intent. Talon apparently knows how to read my mind.
I understand.
Well, I can barely see the decimal place from here.
Yeah, that too.
I just assumed that you were going to the.
All right, so we now have this right here. I can factor out m. So I have 2/5 r squared plus 1.3 squared.
Where did the 1.3 come from?
I know that the rod is 2 meters long.
Yes. Oh, you just subtracted 0.7?
Yep.
Okay.
So when we're getting into does the radius of the putty matter? If I factor 1.3 squared out, I get m times 1.3 squared. Actually, this is 1.3 is h. So I'm gonna factor h out, h squared out. So I get mh squared, and then 1 plus 2/5 r over h squared. Take a moment here for you to convince yourself that this is legitimate math. You can do so by distributing.
You factor out h.
H squared.
Did you switch the places?
Yeah.
Ah.
All right, so now the significance aspect. What is the relationship of r to h? If r is significantly less than h, then this is a tiny number, and then I square it to make it even tinier. So if r is much less than h, then this is close enough to 0.
Okay.
Now, if you're designing a multi-million-dollar fighter jet, don't do that approximation.
Why?
I guess it depends on what your intent is, I guess, in the end.
I want it to blow up.
For those who want to do jail time, go ahead and just cut corners like that.
Sweet, thanks.
So, I did not give you the size of it, and so that was an indication that it's insignificant on the quiz or test. If in doubt, ask. But if r is significantly less than h, then this whole term becomes insignificant, and we're just left with mh squared. That is for the moment of inertia. So what's omega? I'm trying to find the moment of inertia, the initial moment of inertia of the ball.
Like-
And it's going to be, we've gone down to mh squared times omega initial, not squared.
Like denotation? What's
So how
omega?
do we solve it?
Oh. I was about to say angular velocity.
Well, if we're using